Well, very early, students are going to start asking questions that are not on the entire data set, but just on a part of the data set. And that's going to lead us to filtering. So, yep, why should we filter the data set? Like I just said, we might want to analyze subgroups of the data set. You know, that Pokemon data set that we have, students love that one. Maybe they just want to look at a subgroup like water types and see how their attack points distribute. Or maybe they want to compare some subgroups and say, how do the water types compare to the fire types? And let's make some histograms. And so they might create a new table of just water types, a table of fire types, and then make some displays of each and show how those histograms or box plots compare for each other as they look at their research questions. Sometimes, like we've seen in our animals data set, some important information can maybe be hidden or masked because all of the data is combined together. And it's good to break it down somewhat. Get rid of those heavy dogs from the pounds area. And let's just take a look at maybe just the cats or some snails or tarantulas and just see how they compare, because the dogs have maybe skewed, as we have seen, the pounds in our data set. So sometimes that's good to get some subsets for our analysis. We start the students by just looking at row consuming functions. And let's start small with a table we call the shapes table. So here's a small table of shapes with a few columns. And then we give them some functions. And I've just put the 4 functions here that come on this worksheet: is red, is polygon, lookup name, and is triangle. And the students just explore these. And we ask them questions like, what do these functions do? What's their domain? What's their range? So we take a look at some of these, like is red, and look at the purpose statements. Good thing for the design recipe, right? Oh, we see that they consume rows. Oh, every single one of these consumes a row. But the is red consumes a row and checks to see if the color is red. And it produces true or false, a Boolean back to let me know if it is red or not. Whereas same thing with polygon. It's checking to see if it's a polygon, true or false. So the domain for each of these is a row, and its range for each of those was a Boolean, true or false. Same thing for it is triangle. Domain was a row, and it's a Boolean for its range, but this time it's checking to see if the name contains triangle. This triangle, blue triangle. They pass it some of the defined rows, as you can see in the bottom right-hand corner. Pass it is red, blue triangle, and it goes to see it is the color red. Well, no, it's blue, so we get false back. Is red circle red? Yes, and we get true. So they see that that's what the function is doing, is checking the color of the shape. You look at lookup name, however, it's a little different. It still consumes a row. Its domain is a row, but it is now told to look up the name of the shape. And so its range is a string, and it gives back the name of the shape, triangle, circle, and they'll put that in and see. Right? They're all row consuming functions. Each does something a little different. What does all that have to do with filtering? Well, before we filter, let's jump in and do an activity. This is like my favorite one, and if you've ever been to a training, this is something that it solidifies the understanding of filtering, and I would never ever in a million years skip this activity, because you will refer back to it as students are practicing what they're filtering and writing their helper functions. They totally get this and refer back to it. You're going to line up a few students or several students in the front of the room. It's going to be like they are the rows of the data set, if you will. Put them in the front of the class and pick 2 students, a helper function and a filter function, to be with you in the front. You have these cards, helper function cards. I have an example of one here, has glasses. It tells you that you're going to input a student and output a Boolean. So the output is just either true or false. The students is the row of our data set. Our data set is rows of students. For our particular one that we've picked, has glasses. The helper function is just to look and see if the student is wearing glasses, true or false. So you have these 2 students. helper and filter. The helper function is the only one who knows what this card says. It's a secret to everyone else. They're going to have their helper function go down, and they're going to go student by student with the filter by their side, and they're going to say to filter true or false based on when they look at that student in the first row, the first student, if that student's wearing glasses, then they turn to filter and they say true. And then the filter will say keep them. And then if the filter says keep them, then that student will step forward. Go to the next one. If that student's not wearing glasses, then the helper function will say false to the filter, and filter will say, okay, basically I'm ignoring you, step back. And so we just kind of have that student step back. And so on down the whole set of rows, it's all the students in your data set. And then those students that have stepped forward, this is your new table, your new subgroup of your data set has glasses. And your filter has created this new table using your helper function. And now your class gets to guess, what was the helper function? And usually has glasses, they tend to get that one. Some of the other cards that we've created are a little harder to guess, but you want them to guess them. But you can make up your own cards if you wish. But great activity to just hone in and understand that the helper function is needed to feed to filter. And all that the helper function tells filter is true or false, and the filter then picks the true ones to come and create a brand new table. Back to the shapes table, our filter contract, here's our filter function right here, hashtag filter, we just talked about, it takes in a table. And that function, that helper function, it says tester function here because it's testing to see is it true or false. It takes a row and it's Boolean producing. And that's then going to produce a brand new table. Then they look at filter shapes table is red and see that they get a brand new table, just reds. Or they might filter it is polygon and they get just all of the ones that were polygon. The main idea here is that filter is going to produce a brand new table. If they wish to save that, then they need to define it as I did over here. And I encourage that if you have students who are going to use that, let's say you want to do a lot of work on just dogs, then make a dogs table and store that dogs table because it's going to save you some coding and make it swifter for you to be able to code later on and make less errors. Reds here is that I can now go ahead and just do my graphs on reds and not have to put in filter shapes table is red every time I want to use just red shapes. Another thing to think about, we just said that helper function must be Boolean producing, and so the students are asked to put in, let's filter shapes table by lookup name. Remember what lookup name's range was? It was a string. Oh, well here, let's see what the error message is. Oh, we expected it true or false. It must be Boolean. And instead we got triangle. Oh, darn. Yeah, that's because it's reminding us it needs to be Boolean producing. And so, of course, this is now going to upgrade our ability to analyze because we get those subgroups and we can now just go crazy with our analysis. We're going to practice some more with animals, and there's design recipe pages for the students to now create is cat, is rabbit, and not only that, let's go make some displays. I made a pie chart down here from the cats table after creating is cat. Create cats table, and now, wow, I can see the distribution of the sexes of just cats. And then not only that, now let's go on and apply it to our own data set. If you have students now in their own data set, love the design recipe page for here. It reminds them if you're doing filtering that this must be a row consuming helper function and a Boolean producing helper function in order to do some filtering there. There is a building a column help video where you can see more on how to use these row consuming functions.